Hello, One-Away class. Mr. McHugh back with you here on section 9.4. Going to tackle page 4 and objective 4. Wish I could say problem number 4, but it's example 5. Okay, so what's interesting here, this is called quadratic functions as a model. And we're going to go back to a tower or a building, and now we're going to stand up on top of it. And I like to talk about us standing on top of the CWI main campus building and pretend it's 144 feet up in the air. And what would happen if you took an object and threw it up forward at 112 feet per second, and it would go up. It would take the shape of a parabola. So here's my little diagram. There's a building 144 feet. It's going to go up and it's going to come down. I think of this parabola. I don't know if that diagram is not as good as I would like it to be. So it's got the shape of a parabola. When it hits the ground, and if you think of feet as your y-axis, when it hits the ground, you would be at what distance would be at? Distance would be at 0. And so the question here is, when does the object hit the ground? You stand here 144, you throw it up, and when will it hit the ground at 0? Now here's the deal. They give you the model of the quadratic equation, so study this for a second. First thing is, notice that negative 16t squared. This is given to you, so that is from the Galileo problem, example number 2 out of section 9.1, negative 16t squared. Notice they tell you it's 112 feet per second. That's the middle term. Notice the 144 comes from how high the tower is when you start. Okay, and so imagine if we said at time 0. If I put t stands for time, and this s of t, by the way, let me just back up for a second. T is time, s of t. S is a crazy variable. It's distance. I have no idea why they use. I remember this. I don't know why they use s. You got to tell yourself it's the distance above the ground. Imagine if I told you t was 0. What would happen here? This would be a 0. 112 times 0, 0. You would have 144 feet. Is that where you would be at time 0? You gotcha. So just want you to study that. Just understand those equations. If they come from somewhere, they're not just made up. Okay, so the question here is, when the distance is 0, how much time does it take? So I plug 0 into the equation. That's all you got to do to get this started. I know a lot of talking here, but just to get you started, ask yourself, can you pull out and divide by the GCF? I look at negative 16, 112, and 144, and guess what? Divide by 16 on all of them, look what happens. You get a negative divided by a negative. Look, you get a positive 1t squared. 112 divided by negative 16 is negative 7. And finally, 144 divided by negative 16 is negative 9. Okay, so that makes your problem a whole lot easier. Could you do this with these coefficients in here? Yes, but the numbers will get huge. Recommend you to divide by the GCF. Make it easier on yourself. Now that you've done that, look at your A, look at your B, look at your C. I still like to turn around and write those values out. 1B is what? Negative 7. C is what? Negative 9. Like doing that, because now what I can do here is use the famous quadratic equation, because you're dealing with a quadratic formula, and instead of t is time, it used to be x in the formula, no big deal. Negative b plus or minus b squared minus 4ac. Oh, who remembers what this was called? It starts with the letter D. Hopefully you remember discriminant. Okay, a little quiz there for you, discriminant. Okay, so guess what you're doing now? You plugged in 0 for distance. You divided by the coefficient A, happens to be negative 16. It goes in evenly. Simplified the quadratic. Substituted, identified your A, B, C coefficients. Now you're going to plug and chug into the quadratic equation. And you know what? I want to pause here. Why didn't I not do the reverse FOIL? Well, guess what? If you tried to come up with parentheses over here, and you put t and t, look at that negative 9. You cannot come up with factors of negative 9 that add up to a negative 7. Just can't do it. So therefore you have to use the quadratic equation, just to let you know why you're using it. Okay, so now it's plug and chug. So you can see the values. There's negative 7, B is negative 7 squared, A is 1, C is negative 9, and now you're in arithmetic. I call calculating mode, arithmetic mode, chugging away. Negative 9 squared is 49. Negative times a negative is a positive 36. 49 plus 36 is square root of 85. You got your, notice the negative times the negative is a positive 7 plus or minus the square root of 85 divided by 2. Square root of 85, go to like 1 or 2 decimal places, is 9.2 plus or minus. Take 7 plus 9.2 divided by 2. Take 7 minus 9.2 divided by 2. Get that going on your calculator in your head. You come up with a negative 1.1. That's out. Time can't be negative. And you find out your answer is it takes 8.1 seconds for it to reach the ground. Okay, kind of an interesting problem there to think about. It would be cool if we could go out and do some experiments with that and time all that good stuff, but fortunately we don't. Okay, Mr. McHugh here. We have worked through page 4. We're going to check this off and say goodbye for now. Got one more page to do in section 9.4. Going to do a model quadratic formula with data, and we're going to look at this example here. So I'll see you here in a couple minutes here for page 5. Okay, take care. I'll see you.